Everyone, welcome to the explanation. So in today's video we'll be covering the topic that is data abstraction. Data abstraction in DBMS. So this is the continuation of our DBMS video. So what is data abstraction in DBMS? So data abstraction, it refers to the process of hiding the complex detail of data storage and retrieval. So why it is done? Why is data abstraction done? It is done in order to simplify, in order to provide, we can say, in order to provide a simplified view to user. So let us take example of an application where we want to, let us take example of student information system. Okay, so you want to know the record of a particular student whose ID is 1. Okay, so if you type here 1, you are going to get all the information related to that student. Okay, so you no need to know that how these data are stored. Okay, it's not there is no need to know that how this data are stored in the storage devices, or we can say in the memory, in the hard disks. Also, there is no need to know that how these data are organized, either they are in the form of table, what are the keys, what are the rows and column. No, we don't need to know all these things. So this is called abstraction. Abstractions means hiding all the complex detail from the user. So the user can be a layman person. Okay, it is not needed that user is always a technical person. So they are not going to understand that how this data is stored, what is the tabular format. So it means that hiding the detail. Okay, so in the context of type of DBMS, type of abstraction in DBMS, we have got 3 types of abstraction. First one is called physical level abstraction. Okay, so this is the lowest level of abstraction, we can say. This is the lowest level of abstraction which deals with how data is physically stored. Okay, so where the data are going to be stored? They are going to stored on some storage devices. Okay, so this physical level abstraction, it includes the structure of the data, how the data is stored, the format of the data, the methods, the indexing method. Okay, for example, if you are searching for the student with ID 1, so where this ID 1 is going to refer, in which table it is going to refer. So all this comes under the physical level abstraction. So user, they do not interact directly with this storage devices or the indexing or the tables. So okay, so this is called physical level abstraction. Second one is logical level abstraction. Logical level abstraction. Okay, so in this logical level abstraction, it represents the overall structure of database. Okay, so here it also provides the blueprint of database, we can say. So it deals with the describing the relationship between the data. For example, if it is in the form of row and column, what is the relationship between them? Okay, how this data is going to be stored in which model, either this is in the form of relational model or any other model. What is the relationship between all the entities? Okay, what is the relationship between all the entities, what is the constraints between them? So all this is described in the logical level abstraction. So basically we can say that physical level, it deals with the storage, and logical level, it deals with the design. Design means how this data is stored in the tabular format, what is the relationship between the data. Okay, so third level of abstraction, so let's go to the next level of abstraction. So third level of abstraction is view level abstraction. View level abstraction. So this level of abstraction is the highest level, we can say. This is the highest level of abstraction. Okay, so what does view level provide? View label provide we can say a UI interface, or we can say a tailored view of database to the user. For example, if you are going to student information system, you are not going to interact with the table, rather than you are going to get some UI like this, where there will be written student ID. So if you want to search any student, you should put student ID in that particular tab, and then you are going to get all the information of a student. So this is called the view label. Okay, so view are generally they are defined by the queries. We write any query and we are going to get the data. Okay, so this view label, they can be changed, they may be different according to the requirement. It is not always same, they may be different according to the requirement of the customer or requirement of a organization. Okay, so these are the 3 levels of abstraction in that DBMS. Now let's talk about the independence. Okay, so what is database, or what is data independence in DBMS? What is data independence? Okay, data independence means that it is the process of, it is the ability, or we can say the process of making any changes in database system without affecting the application. Okay, it means that if you are going to do any change in the data label, it is not going to affect the application, okay, or how the user is going to interact with the data. It means that if you are going to make a change, any change in the physical storage of data, or if you are going to modify any storage device or any indexing methods or any data, we can say, so the user who is using this database is not going to be affected. He or she will never know that there is any changes happening in the database. So this is called independence. Change in any level of data should not affect other level of data. Okay, so in independence, in data independence in database, again we have 2 types. So let's discuss about the types. So first type is, okay, so first type is physical data independence. It means that any change to physical storage of database, for example, if you are going to modify the storage device, okay, if you are going to organize the file in different way, so any change to physical storage of database should not affect the logical and the view label. Okay, so if there is any change at the physical level, user is not going to be affected from that. Next kind of independence is logical level independence. It means that any change, you can write here, any change in the, or any change to the logical structure of database. So what can be changed in the logical structure? So it can be modification of table, for example, modification of table about their relationship, okay. So these all should not affect the view level of user. So any change in the logical structure, for example, if you are going to change the table, the relational table, the relationship between them, okay, the constraints between them, so it should not affect the view of the user. For example, if I am accessing any database, if I am accessing any student information system, and there is a change going in the table level, in the tabular level, the relationship level, as a user I should never know that there is any changes happening. Okay, so this is called data independence. Fine. So these are the topic for abstraction and independence. So in next video I'll come up with what is a schema and what is instance. Till then, stay safe and thank you.